For motorcycle fans, the sound of a Ducati engine is recognized the world over. It's the sound of Italy, the sound of race winners, and the sound of a company renowned for doing things differently.
Without new ideas and without taking risks, you won't go very far.
But even for a company known for risk-taking and innovation, this bike, the revolutionary Multistrada 1200, is out there.
The challenge we chose to accept was to build a motorcycle that was 4 bikes in one.
It's a motorcycle straight out of science fiction, a shapeshifter that actually transforms from one machine to another. The engineers said it would be impossible to build. It'd never work. But this mega factory in Bologna is testimony to the fact that sometimes it's good to dream. Bologna, in Italy's northern Po Valley. To tourists, this is the City of Towers, home to one of the oldest universities in the world. But to motorcycle enthusiasts everywhere, Bologna means only one thing: Ducati. For the fans, this is a motorcycling mecca. Every other year, tens of thousands of their most devout followers, the so-called Ducatisti, descend on Bologna for World Ducati Week to celebrate all things Ducati. Today, they're more excited than ever as the company is unveiling its new Grand Prix rider, 9 times world champion and Italian national treasure, Valentino Rossi.
Ciao a tutti. Il calore comunque della gente, il colore la differenza di lavorare con una squadra, un team italiano si sente. È stato
Ducati is often described as the Ferrari of the two-wheel world, a mark born on the racetrack. At the sport's highest levels, their competition bikes have won 17 world championships. And their road bikes are generally considered the ultimate high-performance machines on the market. Sex on 2 wheels. All Ducati's motorcycles, including Rossi's Grand Prix machine, are designed and built right here in the heart of Bologna, at their 64,000 square meter mega factory.
È un sogno che si avvera, un giorno memorabile, storico.
Here, all is overseen by Chief Executive Gabriele Del Tocchio.
Non facciamo mezzi di trasporto, facciamo delle
We don't just make vehicles, we make dreams. We make motorcycles that fulfill the dreams of our customers.
Riportare di condurre una moto Ducati.
But embodying the Italian dream isn't easy. From humble beginnings in 1926, Ducati has consistently gambled on innovative designs and pioneered expensive new technology to create their worldwide reputation.
Without new ideas and without taking risks, you won't go very far.
But just a few years ago, this Italian dream turned dark. Like many other high-end brands, the company's survival was under threat. From an economic downturn, culminating in the global financial meltdown of 2008 and 9. Ducati faced the prospect of a radical drop in demand for their specialized, high-performance machines.
Come conseguenza della recessione economica.
As a consequence of the recession, my colleagues, shareholders and I discussed what would be the best course of action to take to react to this crisis.
Reagire a questa situazione di crisi.
Ducati excelled at producing high-end sports bikes, but there were other large markets they weren't exploiting. Tourers, for cruising long distances in comfort with a friend on the back. Off-roaders, for taking on dirt tracks and mountain trails. And city bikes, for the urban commuter, snaking through heavy stop-start traffic. Markets dominated by the world's giant motorcycle producers. True to their risk-taking tradition, Ducati decided not to downsize to survive, but to expand and go head-to-head with the big players in the other motorcycle markets.
Lots of people thought our decision was too risky.
Ducati had faith that their racing know-how would give them the technology to innovate their way out of the recession.
It would have been too easy to cut our costs in research and development to cope with the recession. Actually, we did the opposite.
But there was a major catch, because Ducati could only afford to develop one new type of bike. So which of the other motorcycle markets should they enter? The pressure to decide which way to roll the dice fell to General Manager Claudio Domenicali.
This is the most important investment that we have made in recent times. We are investing a lot in terms of research and development.
Working day and night in the design center, he and his department heads wrestled with this conundrum. They considered all options until they came up with a very unexpected answer.
We started thinking about a bike that could change depending on the rider's wishes. That could sometimes be a sports bike, and others a more comfortable machine for touring and cruising.
True to Ducati's tradition of doing things differently, the team proposed a completely new approach. They proposed the impossible.
When my engineers came to me with the idea, I knew it was a solution.
Rather than take on one new market, the decision is to take on all four with a single bike. An idea that sounds like pure fantasy. Because a bike that's a rocket ship on asphalt needs a completely different design to one that can ride over rough ground. And a completely different structure again to be able to tour long distances with a passenger on the back, or snake its way through city traffic. But Domenicali and his team think it can be done. If, and it's a big if, they can make a machine that actually transforms from one bike to another at the click of a button. Pull it off, and they'll have a shot at securing Ducati's future.
To manage a company, you always have to take some risks. But without risks, there'd be no room for opportunity. We calculated this risk, and we knew it was a courageous decision to develop a type of motorcycle that hadn't previously existed on the market.
Ducati is going to throw 10 million euros at their attempt to realize this dream. Imagining a machine capable of 250 kilometers per hour on the road, yet whose suspension and engine systems can shapeshift to enable it to tackle mountain tracks and off-road, and which can transform again into a nimble city commuter. They'll call it the Multistrada 1200. Now all they have to do is build it. It's 7:30 a.m. The main gates open at Ducati's factory in the Borgo Panigale district of Bologna, and the men and women who work here stream in. Machinery awakens on the factory floor, while in the canteen, the human workers do the same. Those whose workstations are nearby simply walk to their departments. But this factory is immense, so those whose work areas are further away jump onto their Ducati push bikes and pedal off around the mega factory's internal cycle tracks. Over 1,000 people work here, creating Ducati's range of 6 different families of production bikes and their top-secret competition racing machines. It's all spread over 2 vast floors. Designers and engineers on the top floor, whilst the cavernous ground floor forms the manufacturing hub. Behind closed doors, the secretive racing department. Beside it, the engine assembly and testing area, the main vehicle assembly area, the final testing and vehicle finishing area, and the parts supermarket. All the components for all the Ducatis in the world pass through here, ready for workers to pick them up and whisk them off to their relevant manufacturing departments. People like Patrizia, wielding giant shopping trolleys from the engine assembly department.
All these pieces are needed just to build an engine.
For every Ducati, its engine is its heart. A mechanical power plant, which instead of arteries, valves, muscles and veins, is comprised of cylinders, pistons, valves, cogs, clutches and gears. For the Multistrada, this beating heart will have to have not just one pulse, but 4 very different ones. It's the first of many challenges to meet for this impossible machine to become reality. Almost every engine produced in Ducati's mega factory started life as a glint in the eye of the Corsa racing department, situated at the factory's north end. This is the most secretive part of the factory. It's where Ducati's Grand Prix and World Superbike racing machines are designed and built. This is the first time a film crew has ever been allowed into this sanctum sanctorum. Today, they're working on the engine that will power Valentino Rossi's Grand Prix bike. More than 220 horsepower and 19,000 maximum revs, giving a top speed of 354 kilometers per hour. This top-secret work is overseen by Ducati Corsa General and Technical Manager Filippo Preziosi, a man well aware that the cutting-edge advances made by his racing personnel form the foundations of the mega factory and the production bikes it builds.
There are many new ideas coming from the racing area that are now at various stages of development for production bikes.
Valentino Rossi's new Grand Prix engine is going to be unlike any other produced by Ducati. But many of the long line of Ducati racers that have gone before it are so-called L-twins, a layout Ducati has used for decades on their racing machines. With the engines made up of 2 big cylinders angled at 90 degrees to each other in an L shape, rather than being comprised of more smaller cylinders in a row, as is the case on many other motorcycles. The big cylinders give a huge amount of power and torque, and are the perfect shape to fit into a narrow, agile racing machine. Ducati want to use their most proven racing L-twin, the 2008 World Superbike winning Testa Stretta, to power their new transforming motorcycle. But to do so, they'll have to overcome a very big hurdle. A challenge given to project manager Federico Sabbioni.
For sure, the engine is the soul of the bike. It gives the performance, the character, and sound of the bike.
The Testa Stretta racing engine has all of this, and something else too. Enormous power. Too much, in fact, thanks to something radical going on inside it. Unlike most engines, the inlet and exhaust valves of the Testa Stretta's cylinders open simultaneously for long periods on each revolution. As exhaust gases rush out through the exhaust valves, at the same time, the backdraft created sucks huge amounts of petrol and air in through the inlet valves, effectively turbocharging the engine in reverse. All that extra mixture is then ignited, giving a huge amount of power, which is great for the track, but uncontrollable for many of the places the Multistrada might find itself. So to tame this engine, Ducati is reducing the time the inlet and exhaust valves are simultaneously open, reducing the reverse turbocharge effect, the amount of petrol and air mixture sucked into the engine, and reducing the resulting size of the bang inside the cylinder. The result is a less explosive engine that's far smoother at low revs, making it much more controllable in the way it delivers its rocket-like power, and perfect for use in Ducati's Transformer.
What we've done with the Testa Stretta 11-degree engine is not to reduce the performance, that is something inconceivable for us, but reorganize the performance.
This tamed beast is being built just 20 meters from the racing department that spawned it, in the engine assembly and tooling area at the northern end of the factory. Here, the lessons learned from decades of success on the racetrack go into producing engineering marvels for the general public. The engine assembly area is comprised of 2 separate lines, each with 15 to 20 technicians working on over 35,000 engines a year. Assembly line 1 fits the crankshaft and gearbox into the bottom end of the engine. Assembly line 2 fits the top end and sides of the engine, including the pistons, cylinders, cylinder heads, and clutches. Despite this assembly line being ultra high-tech, the engines themselves are hand-built. Here on line 1, the precision-tooled gearbox is being put together.
If this procedure is done correctly, then the gears will turn. If not, they get jammed and won't move. This is a very high-quality system we have here to make sure everything is correct.
Next, the crankshaft goes in. And after 40 minutes on the production line, the Multistrada engine is about to become a single unit. A robot precisely applies silicon sealant along the narrow flange of one side of the engine case. And the left and right halves of the engine are sealed together. Once its retaining bolts are in place, it moves on down the line. At the heart of the Multistrada, and indeed all Ducati engines, is a unique go-faster system, pioneered by the racing team nearly 60 years ago. An engineer called Fabio Taglioni adopted an ingenious way of allowing the engines to run at extremely high revs without being in danger of blowing up. His plan was to use solid cams and rocker arms to both open and close the engine valves, rather than the springs other engines used. For those other engines, when their valves tried to open and close very fast at high revs, their springs simply couldn't keep up, dragging the valves back and bouncing them on the pistons beneath, a problem known as valve bounce. This made the engines run inefficiently, or worse, blow up. By using solid cams instead of springs, Taglioni's so-called desmodromic valves never bounced onto the pistons below, so the engines could run at higher revs than other engines, which meant more power. Meanwhile, the now joined engine is passed on to the second assembly line, where it's waiting for its cylinder heads and the desmo valves they contain.
The heads are put together first. We assemble them, then they're put on. This is a very important bit. They have to perform at a very high level and subject to very high vibrations. So, assembling the heads is done in 3 stages. First, we put them together to allow the gaskets to seal properly, the cylinders and the heads. Then we tighten them with 2 different tensions. At this point, there is nothing more to do than cover it, and the engine is ready. These are the carbon fiber covers. Okay, now that we've finished covering this MTS Multistrada engine, it's ready to be tested. And then, it's ready for the client. Building a Ducati engine is realizing something very personal. You're bringing it to birth. When it's complete, it's something of ours that's becoming something of yours.
This bit of paper is like a patient's medical notes in a hospital. It will stay with the finished engine for its entire journey through the factory. It's now on its way for a checkup, a cold test, where it will be checked over to ensure everything is sealed and functioning. If there's anything wrong, the whole engine will be dismantled and not allowed any further along the production line. It's called a cold test because the engine isn't actually started. The tester fills the engine with oil and the machine runs the engine to test its pumping efficiency and check for leaks. Assembly lines 1 and 2 have done their jobs, because this one has passed. And the Multistrada L-twin tester Stretta engine is now ready to be turned into a motorcycle. But the dream of the transforming Multistrada isn't for one motorcycle, but for 4 motorcycles in one. And for that to be achieved, the racing engine will have to be wedded to a space-age skeleton equipped with shape-shifting suspension systems. Technology straight out of science fiction. All Ducati's racing bikes have innovative chassis and frames. This year's Grand Prix machine for Valentino Rossi is unique in that it has no frame. But all Ducati's previous racing successes have been achieved using a chassis with a tubular space frame. Space frames are perfect for racing as they're very strong, but also very light, which means they're very fast. The design department, led by Andrea Ferraresi, wants to use the same technology for the Multistrada. But they have a problem. A superbike chassis is designed for high-speed racing, where comfort and tight turning circles are unimportant. Great for the track, but not for the streets, long winding roads and rugged off-road conditions on which the Multistrada is also going to have to perform. The challenge is how to address all these issues at once.
Integrare le quattro diverse funzioni senza realizzare.
It integrates all four functions without creating a sort of Frankenstein. Without building a bike that was created by cutting up bits of other bikes.
The design team's solution is to stretch the shape of the chassis, making the bike higher to absorb off-road bumps, but also increasing the length to keep the weight of a passenger or luggage inside the wheelbase. It also has a tighter turning circle for the city. The design department has given the Multistrada its skeleton. Now on the main assembly line, that skeleton can be wedded to its heart, the engine. At 75 meters long, the main assembly line is where the thousands of individual components from the parts supermarket come together as finished Ducati motorcycles. Here, the first part of the chassis to be fitted onto the engine is the rear swing arm. The single-sided swing arm connects the engine to the rear wheel, and coupled with a shape-shifting shock absorber, is designed to enable the Multistrada to tackle not just flat high-speed roads, but also the mud, rocks and dirt trails of the off-roader. Unlike on a road or racing circuit where the surface is flat, and the bike suspension doesn't need to move much to give it a smooth ride, off-road, the suspension has to be much softer to soak up the ruts and bumps. So the Multistrada will have racetrack-developed active suspension, which will use electronics to radically change the behavior of the rear swing arm and front forks when it transforms into an off-roader. With the core of the bike now complete, everything else can be connected to it.
This is the area where we put the frame and engine together, so it is a bit like the birth of the bike.
Next comes the sturdy front forks. They'll take the Multistrada's front wheel, and like the rear swing arm, they're a key part of the shape-shifting go-anywhere suspension. Then on go the handlebars, where the Multistrada's brain will be mounted. Technology that even 5 years ago simply didn't exist. Yes, a brain. Very clever miniaturized onboard computer, developed by Ducati's electronic experts, using racing department technology. It's this breakthrough piece of electronics that makes the dream of the shape-shifting Multistrada actually possible. It's this brain that will control and coordinate the machine's transformation from road racer to tourer to urban commuter to off-roader and back again. It's the creation of a man who's worked at the forefront of motor racing for years, Emanuele Bossetto.
The biggest problem is the available space in the bike.
Signor Bossetto had previously created electronic brains for Ferrari, but in a car, he had much more room to work with. He had to wait for changes in technology before he could do the same for Ducati's bikes.
This has recently been made possible by the miniaturization of all electronic components.
To achieve the 4-in-1 transforming bike, Borsetto must also create several smaller brains, or control units, to control and vary the engine, to actively change the suspension from one surface to the next, and to deliver different traction control for different surfaces. This way, the bike can adapt instantly to different situations.
The biggest problem we had was to make the control units communicate correctly with each other. When we worked with just one control unit, this problem did not exist. Now, the information must circulate efficiently and in a precise way. The control units need to respond quickly, and each control unit must know exactly what the other control units are doing.
So Borsetto's department also has to design an electronic nervous system to link all the brains together. With this in place, the synchronized control units can coordinate the machine's transformations between its 4 very different incarnations at the flick of Borsetto's control button. Set the system to sport, and the engine control unit adjusts the engine to give maximum power and rocket ship acceleration via its electronic ride-by-wire engine controls.
The ride-by-wire is a system that operates the engine depending on the throttle opening requested by the rider. This controls a motor, which changes the performance. Specifically, it operates the throttle butterflies. In the past, this system was mechanically controlled. Now, it's a little electric motor that actively moves these butterflies.
At the same time, the suspension control unit activates other electric motors, moving parts of the shape-shifting suspension into a hard surface-hugging setup for maximum speed. Click Borsetto's button to urban setting, and the engine control unit instantly readjusts the ride-by-wire system to produce less explosive, more controllable power. The suspension control tells the front and rear suspension components to adjust to a softer, more comfortable setup for city streets, while the traction control unit eliminates wheel spin away from the lights.
To produce 4 bikes in one has been the biggest challenge of my life because of its very high complexity.
Back on the main assembly line, only one major piece of the puzzle to build a transforming bike remains. But like so much of this machine, choosing the right wheels is not straightforward. Because off-road bikes generally need larger wheels than on-road bikes. With high-speed sports performance in mind, the designers are going for a standard 43cm wheel, and they're relying on some outside help to make sure this smaller wheel will perform off-road. Help with a deceptively simple component that has its own industry, its own experts, and its own closely guarded secrets. The tires. Most tires are designed for optimal grip on a specific surface, but somehow a tire must be found for the multistrada that will operate in all extremes, from high-speed tarmac to mountain tracks, and that is a really tough challenge. It was up to multistrada project manager Federico Sabbioni to find someone who would take on the job. He approached several of the world's leading tire manufacturers.
The tyre brief required characteristics that contradict each other.
In fact, the tyre's requirements are so contradictory that only one tyre manufacturer responded to Ducati's advances: Pirelli, and their director of testing, Salvatore Pinisi.
I remember the first meetings we had in the technical department very well, with our colleagues in testing, about Ducati's request. Frankly, they seemed to us strong requests. I don't want to use other terms, but they were a bit strong.
Having provided tyres down the decades for both motocross and superbike world champions, they seemed the perfect choice.
Pirelli has vast experience in all four areas, so we have all the experience. But the difficulty was to balance them in one product.
To shod the Multistrada is a difficult request even for Pirelli, because normally tyres are made in completely different ways to do different jobs. For high speed on circuits and roads, you need soft, smooth tyres with very little tread pattern, giving you huge amounts of rubber in contact with the surface for maximum grip. But for off-road riding, you need the opposite. Lots of grooves to channel mud and water out from under the tyre. Hard rubber, so the tyre doesn't instantly wear out on the rough surface. And knobbly protrusions to bite down through the dust and dirt. To work both on and off-road, the Multistrada tyres will need to be all these things at once. After a year of development and over 30 different prototypes, Pirelli are finally happy with their creation. The solution is a tyre with different rubber compounds on different parts of its surface, a so-called bi-compound tyre. Thick, hard puncture-resistant rubber forms the central part, ideal for surviving the sharp boulders and stones encountered off-road, while soft, sticky rubber makes up the sides, giving lots of grip when cornering at high speeds. This is combined with a very clever tread design. Enough grooves to squirt mud and water out from under the tyre when off-road, but not so many grooves that they reduce the amount of power the Multistrada can pour down onto a tarmac road at high speed. And even fewer grooves are cut onto the sticky rubber edges, maximising the grip available in fast corners. The new multi-use tyres are called Scorpion Trails. 4 hours and 20 minutes since its components left the parts supermarket, Ducati's sci-fi transforming bike is beginning to look like a real motorcycle. A few final additions and finishing touches. And the Multistrada is complete. Finally, it can be lowered gently onto the ground and for the first time in its life, be wheeled along. But after years of development, 10 million euros of investment, and the input of some of motor racing's greatest engineering brains, will it work? And will it sell? Before Ducati's new transforming motorcycle can leave the mega factory, the testing department has one last test for it. Or rather, tests, tests, and more tests. In fact, the Multistrada is the most factory-tested bike Ducati produce. Here, exhaust emissions and engine settings are being checked. Next, the whole machine is fired up for the very first time and put through its paces on a rolling road. Now it's time to find out if the tamed racing engine performs as expected, if the electronic control units move smoothly between their settings, and if the suspension morphs correctly on command. At a simulated 30 kilometers per hour, the front wheel is fine. But what about the business end of the bike, the rear wheel, and the engine attached to it? The tester begins to open the throttle, and the revs build. Second gear. Third gear. 5,000 revs and 120 kilometers per hour. Fourth gear. ...135 kilometers per hour. And the crucial engine test point has been reached. Just 8 hours after its components left the parts supermarket, the assembly line has done its job. And the finished transforming multistrada can be passed on to the packing section, where it's pampered, polished, and packed up for the potential customer. On paper, it's one of the most advanced bikes ever made. But what about in the real world, out on the road? How do all the complex race-bred systems actually work, not in isolation, but together, as part of a single transforming motorcycle? On the road, its race-derived 1200cc engine feeds power gently to the rear wheel. The suspension is moved to its most comfortable setting, and the engine's acceleration, potentially rocket-like and exhausting in the raw state, is held back by the onboard electronic control unit. So what could otherwise be a beast to control is tamed to take on the role of the long-distance tourer. Yet, just as Signor Borsetto planned, with a click of a switch on the handlebars, this long-distance tarmac tourer transforms itself to take on the mud and potholes of the off-roader. The electronically controlled suspension physically changes to soak up ruts, rocks and bumps. The engine settings change to give more usable power at lower speeds. And Pirelli's Scorpion Trail tyres push through the mud, clinging to the surface below. But it's on the racetrack that Ducati made its name. So of course, this morphing machine's been designed to be at home at high speed too. With the onboard brain clipped to sport, the engine morphs so the full fury of its race-bred pedigree comes into play. The power rises by a third to 150 horsepower. The ride-by-wire engine controls alter the acceleration from smooth and calm to brutal and race-like. The suspension is now much stiffer, and as the bike leans into fast corners, the soft side rubber of the tyres glues it to the road. Back in the centre of town, the Multistrada's engine and suspension transform again. Power's reduced back to 100 horsepower. The suspension soften, and the stretched space frame chassis allows plenty of turning lock for snaking through traffic. Ducati feels the Multistrada has met all their design goals. But do their customers like it? Because at the end of the day, that's the reason Chief Executive Gabriele Del Torchio had it built.
Lots of people said to us making 4 bikes in one is an impossible task. Well, we did it, and I believe the result is truly fantastic.
In fact, where the business rubber meets the road, the Multistrada passes with flying colours. Sales far exceed even Ducati's expectations. 10,000 were sold in 80 countries around the world in its first year, with the mega factory now producing up to 70 a day. So Signor Torchio's courageous €10 million gamble to help secure Ducati's future is paying off.